just call this the example problem. All right? Got the new one started? So the problem 10.4 in your book, okay? Estimate the mass and feed rate of chlorine and ammonia. Get some good footage of me erasing the board, I guess. Okay. So the feed rate of CO2, okay, so part A here. The flow rate that we're dealing with is 1,700 meters cubed per day. That's 14, we're going to do a unit conversion, 1,440 minutes per day. Gives us 1.181 meters cubed per minute. Okay? The mass of chlorine required, or of monochloramine required, is 2.0 milligrams per liter. This is a goal. Like we know we need 2 milligrams per liter because people have talked about, or people have done research and realized that's a good concentration to have in our disinfection system. So we're going to do 2 milligrams per liter times that 1.181 meters cubed per minute. That's going to give us 2.361 grams per minute. So this is the mass rate that we need. So part C, we're going to use equation 10-5, NH3 plus HOCl gives us NH2Cl plus H2O. This is monochloramine. We'll look at some structures a little later, but monochloramine is the NH2Cl. All right? And then part D, we're going to use equation 10-1, Cl2 gas plus water gives you HOCl plus H plus Cl minus. Part E, we're gonna say, so 1 mole of Cl2 gives you 1 mole of HOCl. That's what we can see right here. 1 mole of chlorine gas gives you 1 mole of HOCl. And 1 mole of NH3 reacts with 1 mole of HOCl to form 1 mole of our monochloramine, NH2Cl. Okay? So we know that we need 1 mole of this and 1 mole of this is the short story. We're just kind of working through looking at our chemical equations to figure out the molecular concentrations that we're going to need to achieve the mass concentration that's desired. Okay, so part F here. We're going to figure out the moles per minute needed. Okay, so we got 2.361 grams per minute divided by 51.5 grams per mole is 0.046 moles per minute of chlorine, okay, Cl2. So this is grams per mole of chlorine, Cl2 on the bottom here. Okay, so G, we're going to feed that 0.046 moles per minute of Cl2. How many moles per minute of ammonia do we need then?
Same number?
Same number, yeah. We said it's a 1-to-1 thing, right? So we need the same moles we're going to feed of Cl2 and ammonia, NH3. Okay. So the gram molecular weight of CO2 weight Something's weird here. Let me erase that part right here. Let's continue with this. Gram molecular weight of Cl2 is actually 70.9 grams per mole, and the molecular weight of NH3 is 17 grams per mole. So the Cl2 that we need is going to be the 0.046 moles per minute times the 70.9 grams per mole is 3.3 grams per minute. And the NH3, the ammonia that we need, is going to be the 0.046 moles per minute times the 17 grams per mole. That gives you 0.78 grams per minute. Okay, so these are our answers. 3.3 grams per minute of chlorine and 0.78 grams per minute of ammonia. Okay. So what happened up here? What was this 51.5? That's what we got to figure out. 51.5 is a gram molecular weight of NH2Cl. Okay, that's our monochloramine gram molecular weight. We knew we needed 2.361 grams per minute of monochloramine. So this is also NH2Cl. That's the molecular weight of that. So we needed 0.046 moles per minute. Of NH2Cl. Okay. Come and get all your stuff that you can get here, and we'll see you guys on Monday.